This is Ask a Biologist, a program about the living world, and I'm Dr. Biology. Before we jump into our episode, I want to remind those who have not subscribed to this podcast, take a moment and do that now so you don't miss out on any of our future shows. Now today, we're diving into a topic that affects many of us, especially kids. What am I talking about? I'm talking about allergies. And when you think about it, why does something as simple as peanuts or eggs trigger such a strong reaction in our bodies? And what if our immune system is doing more than just overreacting? What if it's trying to protect us in ways we don't understand? Joining us today is Esther Borges Florsheim, a researcher at Arizona State University's Biodesign Institute and a faculty member in the School of Life Sciences. Esther is on a mission to uncover the secrets of our immune system, not just how it fights off germs, but how it might shape our behavior, decisions, and even our survival. Her work looks at unexpected ways the immune system interacts with our brain and body. Whether you're someone who has allergies, a student curious about science, or you just love learning about how our bodies work, this episode will open your eyes to a whole new world of possibilities. So grab your favorite snack, unless you're allergic to it, and get ready to learn about the incredible connections between allergies, immunity, and human behavior. Welcome to Ask a Biologist, Esther.
Thank you very much.
So on this podcast, allergies have come up. Not as much as we're going to talk about today. But the immune system definitely gets talked about. But not everybody catches every episode. So can we talk just a little bit about the human immune system?
Okay, the human immune system, or the immune system in general, to all the animals and other organisms that have them, is a tool or a system that is composed of different cells in your body. Different organs can also help to perform that. And the main function of the immune system is defense. So defense, classically understood by defense against pathogens, like microbes, like bacteria, viruses, and things that make you feel sick. So the immune system is this complex defense system full of cells and things moving around. So it's not a static thing. For example, like your stomach is always in that place, your liver is always in that place. The immune system is all over your body. It's in different places and it's everywhere at the same time, and it moves around. So that's part of why it's complicated to study, because it keeps moving around and different cells do different things. So it adds to the complexity. But the idea of having an immune system is that you get protection from a lot of things in the environment, and it helps your organisms to do what they need to do in a daily basis.
Right. For those that want to know a little more about the immune system, in particular about those things with viruses and bacteria that you might think about when you think about the immune system, getting a cold or the flu, we have a fun comic and story called Viral Attack. And that's a good way to dig into the details that we're not necessarily going to go into in this podcast. But we are going to talk about allergies. And it's interesting because there are allergies, like when I was young, I had allergies with grasses. That was a common thing for people to have. But today there are people that have allergies, and it seems like more people have allergies to different kinds of foods. So why do some people get allergies and other people don't?
Yeah, that's the million-dollar question. That's exactly why we want to know that. And to me, it's even more interesting, the opposite question, which is why some people don't get allergies rather than, because usually that's the question, like why some people get so severe allergies that you cannot even have someone eating something with peanut that you can smell that, and that can trigger like a really potent reaction. I was like, why some people have nothing when they are facing that same thing, right? Even within a family. So it seems clear that it's not only genetics, like things that are passed from your parents can contribute to how much of an allergic reaction you have, But this seems to not be the only thing. I think this whole field of allergy now agrees that is your environment in general that is contributing to increasing allergies. What you said about increasing allergies is very true. The number of cases more than doubled in the last few decades. And this has been true for asthma. This was true for atopic dermatitis, for drug hypersensitivity, food allergies is the main one increasing now. So it is increasing worldwide.
So with that said, how does our immune system know what's harmful and what isn't?
Good question. That's what we are asking also. So the immune system decided at some point, this is what we call sensitization or sensitization. This is when you first encounter what later is going to become the allergen. So that peanut thing or milk or eggs or whatever you're allergic to, or grass, as you said, like seasonal allergies induce. So this is the part that is hard to study in humans because you don't know when people first encounter those things. And probably those first things are the ones that your immune system are going to determine, is going to look at that thing and say, is this good or bad for me? And sometimes in people who become allergic later on, is because your immune system looked at that thing and said, this is probably really bad for you. So I'm going to mount this type of response. And then later when you get exposed to that thing, you will have a very intense response because your immune system had decided long ago that that should not be good for you.
Which makes a lot of sense for those that develop allergies early on or they come in contact with something for the first time. I don't know if I'm atypical or not, but when I was young, I had severe allergies against grasses, in particular hay fever. And as I've gotten older, they've gone. What was going on with my immune system?
So this and the opposite is also true. And this is especially true for seafood, for example, and shellfish. People have eaten this type of foods their whole lives. And then suddenly when they are 30, 40, 50 years old, they start reacting against it and become anaphylactic and can never eat that thing ever in their life. So the two stories happen. What you said is more common, to have allergies when you were a toddler, a child, a baby, and then you grow out of them. That's the most common. We don't know what's the reason for that. We think we were becoming tolerized. And that's what people try to do when they do immunotherapies. They try to make you become tolerant, meaning they make a trick so your immune system stops seeing that thing as a noxious, dangerous substance and starts seeing that, okay, maybe I don't need to react every time I have that thing there. So you naturally did that, and that's where we have some evidence that's how we should treat allergic patients, which is the main idea is immunotherapy.
So is that a little bit of peanut butter at a time?
Exactly. It's a tiny bit every day, and you start increasing the amount of that. And that presumably works well for a lot of people for certain allergens. Sometimes it only works while you're doing that. Some people report that once you stop doing this, you go back and you have allergies again. For some people, you can cure your allergies for the rest of your life.
Right. And we'll remind everyone, do this with a physician. Don't do it on your own. Okay, so allergies. Do you have allergies?
Actually, I do. I have one. I have a nickel allergy, which is a very weird one, like jewelry that is not gold and has some type of like either nickel, copper. Yes, that, which is a weird allergy to have. It's like, why do our bodies care about nickel?
So what brought you to study the world of allergies and the immune system?
I liked infectious diseases a lot when I was in college, and I really liked doing research in biomedical sciences. So I think the immune system was my first entry into this world. I thought diseases in general that are contagious and infectious were very, very interesting, and I wanted to study those. But then once I started studying those types of diseases, like bacterial infections, for example, I heard in my immunology classes that there was something even more puzzling, because bacterial infections and other pathogenic or microbial infections we kind of know what are the immune responses that are triggered and how the immune system detects those bugs and how it responds to it. We don't know the details, but we still know more or less what happens. When we get to different types of toxic stimuli, like allergens, for example, and other things, we don't know anything. So that captivated me more than anything. Allergies were a thing that did not fit the paradigm of immunologists. Immunologists were like, oh, we know how things work. We know how we detect things that are bad for you. But then you go to other things like toxins and allergens and venoms, and we're like, okay, this is inducing a very strong immune response. People know that when they get anaphylactic and almost die. So how don't we know what is going on there? So then I moved fields a little bit because I thought that was more interesting.
You mentioned that, but there's a link that we don't always investigate, or at least I hadn't heard was being investigated, was the link between the immune system and the brain. Let's talk a little bit about that link, because it seems like you have some ideas in that area.
Yeah. Again, all the research that we do is we look at what happens in infectious diseases first, which is the more established and known thing. Like what happens when you have a cold or a flu? We usually develop what we call sickness behaviors. And you can relate to that if you ever got sick in your life with any of these bugs. You can relate to things like you don't want to eat, you feel tired, you don't want to hang out, you sleep too much, you have fever, and so forth. You don't want to hang out with other people, so you have an antisocial behavior. All of those things together we call sickness behaviors, which we don't like those things, obviously, because they make us feel pretty bad and we feel pain. But those things are actually very important for you to cope with this infection. You have to have those symptoms. You have to have those things so you can get better, if that makes any sense. And the second point is that it's your immune system that is making you feel like that, just so the immune system can work on fighting the infection for you. So the immune system has this dual role. One is we're going to deal with this bacteria, but we need you to lay down. We need you to stop moving around. We need you to not see other people. We need you to not eat or to eat specific things depending on the infection, like starve a cold, feed a fever. So this is the interesting part where we start being more interested because, okay, how the immune system deals with the bacteria, that's more known. But how does the immune system tell your brain on purpose? This is not just a side effect that happened. It's on purpose. We need to make you feel like that and have these types of behaviors so we can do our job fighting this bacteria or viruses. So that part is less known. Again, it's more known when we're talking about a cold or a flu, completely unknown when we're talking about allergies. So our question was an obvious thing. It was like, if your immune system acts in your brain to change your behavior during infection, would that be the case in allergies, which is also an immune response, but it's a completely different immune response than a bacteria, for example?
Right. Hives or
itch,
yes, or swelling and
yes,
all those sort of things. So when we think about that, then the brain basically says, okay, stay away from people, shut down for a little bit because I'm busy battling this bacteria or this virus that's coming in. With the allergies, as we said, here we have, I get a rash. Okay. So I'm itchy. A little rash is okay. A lot of rash is a problem. A little swelling, a little inflammation is okay. A lot is a real bad thing. It could be deadly. So what is going on? This, again, is back to the immune system talking to the brain. And you're saying the immune system is sending signals to the brain. It's not the brain sending signals to the immune system.
Oh, that's happening too.
Ah.
That's definitely happening. And that's another reason why we started being interested in this relationship between nervous system and immune system is that those symptoms that you just mentioned, right? Like itchy and edema, which is like swollen tissues and so forth, like vomiting, diarrhea, and so forth. Those things are all neuronal reflexes that are normally felt by anyone. Like, you don't have to be allergic to feel the symptoms. Everyone has experienced those things in their life, right? You itch when you have a mosquito bite, for example. That's not an allergen. So you have those normal processes. The whole idea of all of those symptoms is to get rid of that thing that is noxious for you, that is dangerous for you. So the immune system is doing that. The immune system is now trying to tell the nervous systems, like, hey, there is a substance here that will cause a lot of trouble, so we need to get rid of them immediately. So you have this immediate reaction, and your immune system might think that this is really important because it's a matter of minutes you can have those types of reactions, right? So that's kind of the idea here. In the brain, we had no clue what was happening. So that's when we went to study. It's like, okay, we know about these reactions like itch, but you don't need the brain to do all of those things, like diarrhea, vomiting. You don't need the brain necessarily for some of those things. So what about the brain and behavior, for example? What type of feelings do you have when you are allergic compared to when you have an infection? So we found that, interestingly, when you are under an allergic reaction or an allergic response, you feel more anxiety or an anxiety-like behavior. So first you have an avoidance behavior, which is really interesting. That means is your system trying to tell you, hey, stop eating or drinking that thing that is making you potentially sick. And we notice this very quickly. So we do experiments to show evidence that that's the case. So this is the first thing that happens. It's what we call aversion or avoidance behavior. And this is known in humans. Like, pediatricians tell me all the time that kids have this. They show this all the time. Toddlers, sometimes I think they know that they're allergic before their parents notice that they are allergic, because they start refusing eating or drinking something that can be potentially allergic. The parents later will recall that and say, oh yeah, my kid was indeed trying to refuse when I had the food with this particular allergen, and so forth. So the first thing is that you try to avoid that, which is a very good mechanism, right? It's extremely strategic, right? It's a good thing. If something is causing you pain, you avoid that. You stop doing that. You don't go to that environment, and so forth. Now, for example, if you are in a situation that you cannot avoid, let's say you ate that thing, it's too late, you already ate. Your system tried to tell you, like, you should avoid this thing, but you didn't. You ate that thing, probably because it's delicious and full of things that are full of sugar or full of salt or something that you really like. So you didn't notice that there was that allergen thing, and then you waited. Now it's too late. What happens now? So now your brain's going to go on mode 2. It's like, okay, we tried to avoid. That was too late. You cannot avoid. Like seasonal allergies, you cannot avoid. Those trees and grasses are out there attacking you all the time. Obviously, they don't care about you, but they're there in the environment that you have to be in. So there's no way to avoid. So the second mode of your brain is like, okay, I'm in an environment with this noxious, dangerous thing. What do? Then they become slightly anxious. And it seems to correlate with the feelings that allergic individuals have. So this is well reported with people with asthma, for example, with hay fever. So anyhow, we always thought that this was a side effect. I was like, oh, of course you're feeling anxious. In the case of asthma, for example, it's like, yeah, of course you cannot breathe. So no one paid attention to that symptom as much throughout the years. But now we think it's not just a side effect. We think that, again, the same analogy as the immune system in case of infection, saying, hey, brain, do that so we can deal with this dangerous thing. So your brain's probably trying to tell you something and like, behave like this. If you think about animals in the wild, a little bit of anxiety could be protective. So I think it has a heavy weight, this type of word nowadays, because of mental health, and we're going to get to it. But a little bit of anxiety is good because it makes you be aware of your environment and potentially prevent things. So we know that, for example, if you think of an animal in the wild, if you are not anxious at all, you would just go out and not care about the presence of predators, for example. If you have too much anxiety, that's also not good because that's going to prevent you from even going out of your place and looking for food, for example. So you cannot live your life. You cannot eat, drink, reproduce, socialize, anything. So you have to have a little bit of anxiety to be aware of predators, but not too much that would prevent you from going outside, for example. So in the case of the immune system, it's triggering just a little bit of this anxious behavior. The good news is that it's temporary. We found that it only lasts while the allergic response is maintained. So this cannot be, for example, the main cause of people having anxiety, for example. We think that it could be helping, making people susceptible to that, but that cannot only be explained by that. And we don't know what's the consequence yet in humans. We don't know, like, why is anxiety a good thing to have when you have allergies? How does that help you cope with this allergic reaction, for example? Does it get any better? That's what we're going to try now. Like, if we prevent them from having anxiety, which is what you were asking, what does the brain cause in the immune system? So that's the question now. It's like, if we block this behavior, do you see any response? Does the immune system act differently, right?
Right.
We don't know.
Okay. Well, this is why we do science, right?
That's right. We're still doing it.
If we knew all the answers, we wouldn't need to do it. So this anxiety, you can almost say hypersensitive, more in tune, modern day spidey senses are a little more turned on, and maybe it keeps you from going out for that bike ride that might cause problems if you were talking about hay fever, because you're thinking, in this mode, I probably shouldn't do that. Maybe I'll stay inside and maybe exercise. So you're talking about this relationship between the immune system and the brain, and it's a two-way communication. Okay. Is that the big question you have for the immune system, or is that just one of the big questions you have for the immune system?
It's one of the big questions we have for the immune system because there are so many not known things that this is one of them. We are still trying to understand how allergies occur in general. It's like, why do we get allergic again, or why some people don't get allergic, which was your very first question to me, and we still don't know that. But that very idea is still not solved in this field. We're a little stagnant, I would say, in this field. So we need different ideas. That's one of the reasons why we started looking for different tissues. Maybe we were too focused on the immune response, and maybe the answer is elsewhere, maybe in the brain, maybe in another tissue. So my main question is how the immune system detects things that are not pathogens. Because for pathogens, we know, it's like, oh, we have detectors for specific molecules that are in pathogens. This was like 30 years ago that we figured that out. It's not that long ago, but we are now asking questions like, what about other things in the environment? Because we have so many more things that can cause us harm than not just pathogens.
Right. Besides those viruses and bacteria, we've got a lot of other things that are going on.
That's right. Like allergens, phytochemicals, these xenobiotics, which are these compounds that we are putting in a lot of things in like modern environment, for example. Again, allergens, poisons, phytochemicals, drugs, and I call this group toxins in general, poisons. Those are things that are not pathogens, so they're not contagious. They are not like a virus or a bacteria. They could be inside, or a bacteria, for example, can make a toxin and you feel sick because of the toxin, but they are usually not within pathogens. So for those things, we have no idea how the immune system senses those, but we think that the immune system is the major defense system, so it should sense those things or detect those things and do something about it. So those are the two questions that I have in general. Allergens are one special category of that, but the major question is, how do we detect things that are not microbes, and what is the function of the immune system in protecting you? Or is the immune system just trying to make you sick? That's what we think that happens in allergies. That's the current idea, is that, oh, your immune system is just dumb. It's just misunderstanding what is happening and is just mistakenly targeting things that you should not do. We don't think that's true. We think that the immune system is way smarter than that. We think that this immune system knows something that we don't, and they are acting accordingly. We don't think that those things are completely innocuous, neutral things.
So, for example, picking on peanut butter, we don't know what it is for those that have the reaction. We don't know what it is that's causing the reaction.
We totally know. We know exactly what's causing the reaction, but this is the part that is complex. The thing that causes the reaction was not necessarily the thing that made you induce that response at the first place.
Okay.
That's different. So, for example, a peanut has a lot of different compounds inside, right? So when you react to a peanut because you're already sensitized to this peanut, you're seeing the part of the peanut that is the most abundant, for example. But that's not necessarily what, in the first place, induced that reaction on you. It could have been other things inside of the peanut that induced the response, and now your immune system is seeing something else, if that makes any sense. I think the analogy would be, for example, if someone lights a match and starts a whole fire to the point that it burns down a house, the firefighters were not called because of that match, because no one knows where that match is and what caused the fire, right? I think that's the analogy. The firefighters were called by the neighbors because they saw the house was in flames. So that's why they called the firefighters, which are the immune system in this case. But what caused the fire was the match, was something different. So that's not what induced the firefighters to come in the second place, but that's what induced the fire in the first place. That's the analogy.
Right. So our body was no longer looking at the matches. It sees the fire and it says, oh, there must have been a match.
That's right.
Okay.
That's right. That's what allergies are.
So then how do we tell it not to worry about the match and or the fire?
For the immune system is a hard job because they are trying to protect you. They are like, look, whatever, if it's that match or whatever is related to that match, I'm going to protect you from. It doesn't matter. It's what we call better safe than sorry. I don't care if you never eat peanut in your life anymore. I am going to protect you because that thing could cause something really bad on you later in life. That's what the immune system is trying to tell you. So for them, it's okay if you never eat peanut or milk or anything ever again. It's like, okay, oh well, that's the cost of you being alive for much longer, for example. So the thing that we don't know is what are the matches in these analogies? Like, what are the things that caused this at first place that we are seeing as a noxious thing, as something that caused some danger or can be actually really bad for you? We don't know that, but in a lot of the allergens, we do have some idea that are things that could be actually really bad for you. Nickel, the metal that I'm allergic to, for example, is supposed to be pretty bad for you. Long-term contact with nickel increases a lot of susceptibility to cancer and potentially other diseases. So the allergy to nickel might be a protective mechanism for you to not develop those things later in life. So I'm protecting my body by having allergy to nickel because now I'm not going to wear that ever again, this type of jewelry. It's protecting you in a way. For example, when you get allergic to shellfish, most of the time it's because there was some other bug that had a toxin and it's contaminated in your oyster, for example, or in your shrimp. They carry something that is a toxin, a real toxin. So the shrimp is not a problem. The problem was the toxin. But the immune system saw them together. So it doesn't know anymore what is a shrimp or a toxin. It will target both things because it will think that whenever you eat a shrimp, it will come with a toxin. So it's like, I don't care if you never eat shrimp. I am going to target those things.
Do people then with allergies have like an advanced immune system over the rest of us?
That's a good question. I don't think so. We don't know. That's the answer is we don't know. But that's a good point. That's like maybe it's better in detecting things. That's why we call them hypersensitive individuals, right? And I think that's at many levels. I think not only the immune system, but even their neuronal system might be better able to detect things. And it's always a threshold, right? Like taste, for example. Some people can taste something bitter very quickly, and some people take much more of that food to finally perceive that taste. The immune system is probably similar. And people with allergies probably are people that can sense things a little bit more detailed or faster than others. I wouldn't think that this is a general thing for everything because the immune system is complex. So maybe it is true for this type of stimuli like allergens or this type of challenges, but maybe that's not true for other things like viral molecules, for example.
Well, if nothing else, we are learning that we have a really complex system that we need to learn a lot more about.
It is.
Huh. Well, Esther, on Ask a Biologist, I always ask 3 questions of my guests. You ready?
I'm ready.
Okay. The first question is, when did you first know you were going to be a scientist? And, it's kind of like that aha moment, or maybe you have to think back and say, oh, well, actually, this is when it started.
That's a hard question because I never had, I don't think, this like, oh yeah, I'm going to do this forever. I always left it open to like, this is what I'm interested now, but later, I don't know. I think I end up doing biology because I was interested in diseases in general, and also because I was a good student in biology. So it was kind of a natural thing. I like biology. For me, it's easy, and I end up studying biology. It was like opportunities that showed up. I was guided by curiosity. Then I was planning to do infectious disease, and then I got there to do infectious disease. And then I thought, oh, but this allergen thing is much more interesting because it's more puzzling. We don't know anything about it. Then you jump to the other one. Then you start doing the other one, and you're like, oh, what about the brain? Let's look at that too. So I prefer to leave it open. Like I never had this aha, this is what I'm definitely doing for life. I'll leave it open. You can do science communication, you can do movie production and be a scientist at the same time. It's just an extension of what you're doing. So I could do a lot of things being a scientist, right?
Right. A lot of my guests do recall certain moments that are turning points. But I think you got to the heart of it is just about all of them, if not all of them, are curious. Yeah. And it's their curiosity that has led them down their paths. Okay, I'm not going to take away your curiosity. You're going to keep that. But I am going to take away all your science career.
Okay, good.
And I'm going to take away teaching. That's something that a lot of our faculty love doing. So I'm going to take all that away from you. This is just a mind game, so I'm not really taking it away. What would you be or what would you do?
That's a good question. I'll be an explorer because that's the other thing I want to be as a child.
Explore the world?
Explore the world, travel around, like an anthropologist, for example. Be able to get to know different cultures, how do people live, different languages. I don't know if there's a job that can do that. Maybe if you work for like National Geographic, for example, and you would go explore. You could be a photographer also, but I'm pretty bad at that. So maybe an explorer is better. Go to cruises in Antarctica or go to all the exotic and remote places we can still find on Earth.
Well, that's great. So the last question is, what advice would you have for a future scientist?
My advice is to read as much as possible. Read things that you like. I think there's nothing like books. I think we're flooded with internet stuff and social media, but there's nothing like a book for your mind to be inspired by. And read what you want. Read anything. Inspiring things that make you curious. Could be fiction, could be nonfiction, ideally both. So just read as much as you can.
I think that's wonderful advice. And for those that want to get a little bit closer to science, on Ask a Biologist, we have these articles that are called plausibles, and they're a relationship with the Public Library of Science. It's a journal that's out there for scientists. And what they are is they're primers. So you can get the layperson's view of a primary research article that's directly linked to the primer. So you can get the overview, and then you can try, and I always say try because scientists, while they do great at science, they're not always great at writing about their science. Part of it is because they use shorthand, things that they use within their groups. It makes it faster to communicate with other scientists, but it seems like a foreign language to anyone else. So try out the plausibles. They're fun. Esther, I've had a really great time learning about allergies with you. Thank you so much for sitting down on Ask a Biologist.
Thank you.
You have been listening to Ask a Biologist, and my guest has been Esther Borges Florsheim. She's an immunologist that's also a researcher in the Biodesign Institute at Arizona State University, and she's also a faculty member in the School of Life Sciences. Now, if you want to learn more about what she's been doing, we'll include links in the show notes, including a link to her profile that we have on the Ask a Biologist website. This podcast is produced on the campus of Arizona State University and is recorded in the Grassroots Studio, housed in the School of Life Sciences, which is an academic unit of the College of Liberal Arts and Sciences. And remember, even though our program is not broadcast live, you can still send us your questions about biology using our companion website. The address is askabiologist.asu.edu. Or you can just use your favorite search tool using the words Ask a Biologist. As always, I'm Dr. Biology, and I hope you're staying safe and healthy.